right, welcome everybody. My name is Brian Reel with Computer Aided Technology. I'm one of our senior field tech managers. We have two across the country, and I am going to describe a little bit of what I would consider designing with intent. We've probably heard the phrase design intent inside of SolidWorks. A little bit of repeat information, but hopefully some good pointers and tips and tricks to use in the future as well. So as a user, I thought I was pretty good designing, if that's not too conceited to say, but I did have my fair share as a new user with creating what I would call angry models, things that maybe weren't exactly the way I wanted them to react the way I wanted them to, but angry models, sometimes SolidWorks crashes, doesn't do things like I like. The whole what in the world was I thinking moment when I decided to draw it that way or design it that way, but again, that's how you learn as well. Then I took a SolidWorks Essentials class, and my mind was, or eyes were extremely opened up to some of the different ways that I could draw things and design things to help take advantage of how I thought my parts would change or update over time. That again is part of design intent. In putting together this presentation, I wanted to focus on more than just how to use modeling, but also things that go along with that modeling process, some thoughts that you would use when you make that particular model. Often, sometimes people will ask, what makes a good CAD designer? You might think of someone who is creative, good attention to detail, maybe someone who can take an idea and really from its inception and develop it and create good innovative designs from that. Good designers also know how to use principles like manufacturing processes. They're possibly going to the SolidWorks forums, reading about the product, about new enhancements, having discussions with their resellers, looking at YouTube videos, and just trying to gain as much insight as they can. But what makes a designer great? So a great designer is probably everything that I just mentioned, but they also use this information to help create what we would call fully associative models. These models can be made up of specific features and modeling techniques that really capture that design intent. So if you think of what is design intent, this is the description that SolidWorks gives for that. Basically saying how your model behaves when dimensions are modified. Okay, that's kind of vague, but that's basically right from the help file, okay? If you've ever modified dimensions on a part that maybe you designed or somebody else designed, sometimes that part changes in a way that you didn't quite anticipate, or you don't have a good understanding of why it's updating the way that it is. To me, design intent is so much more than just understanding how your models behave. That's why, hopefully, you'll get something more from this presentation. So, you might ask yourself, before you even open SolidWorks, having a good idea of what type of product you're going to design. Maybe some of these questions you might ask yourself. What purpose will this design serve? How's it going to be used, right? How will these parts go together? What's the assembly process with those parts? What materials are we going to use? And really try to envision how this model will evolve and work throughout its lifetime of the product. A little forethought in your design can really save yourself some time and possibly heartache in the future. One of the things you might consider when you start sketching the initial part, so we'll focus on the sketching of part design, features of a part design, and then also some assembly design intent features. So when you create a part from scratch, really before you start that initial sketch, take a moment to kind of consider what plane to start with. How's this part going to be situated in real life? Is it going to be sitting on a surface? Is it going to be mounted sideways? If you model your parts using planes that make sense, they're part of the design, I think you really get to enjoy how that part functions in the assembly side, maybe for the drawing side if you're worried about placing the views, but it's just something to kind of consider that orientation of the part before you get too far involved. Talk about that a little bit more in just a bit. Also make use of the design origin, right? The 000. You want to consider what I would consider the best profile. So the first profile is one that might be the best because it's our base feature. The most of the geometry is possible. Making use of the origin, in this case we have the origin in the center of the model. Take advantage of symmetry, if I can do that. Keep that origin in the middle, especially if it's a symmetrically designed part, right? We take advantage of that. Maybe create center lines as an axis if we're going to create a revolve feature. Again, have that axis line up with the origin of the part. Having a properly selected origin or properly positioned origin can sometimes make assembly much easier than what it was. When you're also sketching, kind of a habit to watch for is what we call system feedback. So as you're moving your cursor around your model, either sketching or creating different shapes, SolidWorks is giving you some feedback. Things like, this is the vertex, this is the edge, this is the face, looking for relationships, the inference lines, right? Knowing that these two lines are going to be perpendicular because I'm following that yellow dashed line. So using some of these techniques can also speed up that sketching process, but you're capturing, again, how this part's going to be created. Parts of the geometry needs to be perpendicular, parallel, etc. Use those relations, not so much dimensions all the time, but use relations in your geometry to help constrain that part. Little trick, sometimes, as you're sketching your sketch, SolidWorks wants to be a little too helpful and wants to add these auto relations. Do they have that experience? A couple of head shakers out there.
Never too helpful.
Never too helpful, right? Yeah. But, you're utilizing those, or I believe it's the Alt key to bypass these auto relations. So Alt key is kind of a temporary, hey, quick, trying to help, let me do what I want, and then come back when you're done. So nice little option there if you haven't used that before. Thinking of the sketching process, once you've applied your relations, the next step is typically creating some type of a dimensional floor plan or an idea to follow. In this case, we're choosing which dimensions are going to be driving the design. Might not necessarily be manufacturing dimensions. These are more part designing, controlling the way the part updates over time dimensions. So smart dimensioning inside of SolidWorks, those dimensions drive the model, right? That's the whole purpose of parametric design. What values do we know? What is important for the production? You could reuse those dimensions. Sometimes you have to add some extra reference dimensions to properly convey that to the shop. In this example here, we've got these three different sketches, basically the same geometry, just dimensioned three different ways. So what is important? The top right one here, we're focused more on symmetry. So I want things based off of the center of that hole or that origin. The holes are equally spaced on each side of that. Maybe the bottom left-hand corner, I'm more worried about keeping the holes a specific distance from the edge of the part. So that's something that I've dimensioned that way. Or the right-hand bottom example, I'm simply saying that that first hole is a certain value, and then maybe I've veered to get to the other side. So one dimension is driving both places in that case. Other design intent options while in the sketching mode. In this case, if you're creating a revolve feature, I mentioned that just a bit ago, we have a good chance that when you're creating that revolve feature, you're really just modeling half of the part. So if you dimension it, it's basically the radius, not the full diameter after it gets revolved. So a nice little trick is you can utilize the center line command or a sketch entity. And as you dimension from one edge to the center line, not the end point of the center line, but the center line itself, you go beyond that, or in this case below it, and we're getting doubled values. So those will have a diameter symbol once this sketch is fully revolved. So another way to plan for the drawing side by placing your dimensions with this doubling value, when I import, if I choose to import annotations to the drawing, they're automatically going to have the diameter symbols, and they're driving my design at that point as well. Please, 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 fully define your sketches. If not, I'm going to come find you. All right, fully defined sketches. This is a wonderful tip. If this is the only thing you learn from my 40 minutes of rambling, I've considered it a success. Fully defined sketches. If you can't quite figure out why this sketch won't become fully defined, there is a nice little tool while you're inside of the sketch, allowing you to either access from the command manager, fully defined sketch. You can also right mouse click while you're in the sketching mode, just outside in the open area, and you'll see a right click option for fully defined sketch as well. It will prompt this kind of a property manager list of choices over here to the side. So I'm choosing things like what relations to add, what dimensions to add, what style of dimension, where to attach the dimension. And SolidWorks will go through and find anything that is blue and hopefully turn it into a black, fully defined entity. Once that happens, you don't have to necessarily leave what SolidWorks thinks you're missing. You can always delete it, reattach something else, but it shows you this is what you need to go fix. This is what we think can do it. That might trigger something. Oh, okay, I want to dimension it from that edge, and I can still fully define it my own way. You're not stuck with what SolidWorks wants to do, but it is a guarantee that I won't have underdefined sketches, right? If I at least fully define, I should be good, and I can move forward. All right, I'll get off my soapbox. Yeah, I've never found a good case for this either. There is the option to just simply select your geometry and fix it. But guess what? It's never going to update. Maybe for a reference to design something else around it. I don't know.
I use it when I bring in DWGs. Like
when you bring in exported or imported files, DWGs was an example. That might be a good case. I'm just going to plop it, stay where it is, and then I can create other things around it. Sure, that's a good idea.
It's also a nice way if you got to go from like Solid Edge or Inventor to SolidWorks, doing a CAD platform change, and you're not doing any design intent differences. You can be a way to quickly get through a backlog.
Yeah. So we're working with other legacy data or files that we might have. We're not quite ready to cut the cord on that, but I can bring those files into SolidWorks. Again, fix relations or fix that sketch for the future, like going forward after that. So, good point. Good point. Any other suggestions? I think we had a couple of good ones there. All right. So again, just kind of a summary of design intent in the sketching mode. We find that try to keep your sketches simple. Simple sketches are easier to edit, less time to produce or to consume inside of SolidWorks. It rebuilds faster. The less amount of entities that you have, the least amount of entities you have, the faster it will rebuild. Sketch your geometry to the approximate size. That's why that little indicator pops up while you're sketching. Get it to that approximate size, and then add your geometric relations to properly, keep things updating the right way, and then add your dimensions after that. So sketch with some accuracy, relations, and then dimensions. Always when you add dimensions, it's gotten better over the years, but adding your smaller dimensions first usually helps. The auto scale that came out 8, 9, 10 years ago, something like that, does help, but it's just kind of a good rule to follow. And then lastly, once you figure out how this part might change or update in the future, try using equations and global variables to have your model update the same way, or you're keeping certain rules in check while you're doing your updates. So global variables and equations are a great way to keep the model doing what it's supposed to do, right? Kind of a rule book to follow. If anybody's taken a SolidWorks Essentials class, this is repeat. Anybody willing to admit it? No? It's all new to you? Okay. So here's an example of one of the first models we show in the class. This is a part, pretty simple part, a step shaft. We like to highlight that there are many ways to create this model. We'll go through each one of those different options here. So the first example is just that simple shaft where we might choose to create option A. So it's just a bunch of basic extrudes. I'll go into more detail in just a second. Second option, this one shows to use a revolve option. So a little bit more simple, less features. And the third option is kind of the opposite, where we start with a piece of stock material and we remove that with a series of cuts, much like the production method might be. So if you look at those three options, the first one's called a layer cake approach. And what we do is our part grows a feature at a time. So in this case, we start with the base circle, our base feature. We draw a circle, we extrude it, we get that highlighted blue section that you see on the screen. Now, our second feature is going to be taking the first face that was created, draw another circle, extrude again. And we just keep doing this over and over, and it looks like a layer cake, like a wedding cake. We just keep stacking on top of it. So at the end of the day, I have 5 different sketches, 5 different features, but they're all kind of connected together, one face to the next. Perfectly valid way. Our second approach is what I call the Potter wheel approach. So we choose to create one single sketch, kind of like a cross-section, half of a cross-section, and then we revolve that around that center axis. So at the end of the day, we get a single sketch and a single feature. Again, if you're trying to have a nice, tidy feature manager, this wins the cake, right? It's an easy one. However, it has its negatives as well. Maybe not as easy to modify. A lot of other dimensions to look at when you're trying to edit that sketch. I don't have any options to turn off certain cuts or suppress features. It's all or nothing. Our third approach we call the manufacturing technique. And this is an example where we start with a piece of bar stock, let's say, and then we remove material by creating a series of revolved cuts. So we peel away a layer at a time. Very traditional to manufacturing. We're going to chuck it into a lathe. We're going to turn down the different diameters as we go. 4 features compared to 5. 4 compared to 1, a little bit more, right? But each one is somewhat independent from the others. There are still some connection to those, obviously, but just another way to model that part. In this case, I would probably choose this option because that's how the manufacturing would do it. If I was going to go build that, sometimes I try to model like I'm going to build, and that resonates with me for my particular mindset. So the typical question that we get in class is, which is the right one? Right? There's 3, which one's right? There really isn't a right or wrong. It's just 3 different ways to skin a cat. And what we're seeing here is our model decision should be controlled by either the production environment or how we see this part updating in the future. What are typical updates, typical revision, things that might change? Not that we all have crystal balls, but it's nice to kind of have a little bit of forethought before you start, creating that part. As long as there's a nice logical structure, we're probably okay. As long as we take advantage of some of those very basic techniques of origin, symmetry, possibly fully defined sketches, at the end of the day, we're happy with the part. So a little more detail. Again, the Potter wheel, we talked about that, where it's just one simple sketch, kind of limiting. I like to have options when I model things. It's nice to have the ability to turn something back on or off if I choose to. This I really don't get that option with, right? It's one single sketch, not the easiest thing to do. Layer cake approach, again, is not too bad, but again, there's a lot of features to look at. I have to know that this is connected to this, which is connected to that. So sometimes that update might be a little tricky. The manufacturing, again, it's a single shaft. That's not going to change. It's just the cuts. And I would think if this part's going to have any updates, it's probably going to be the diameters of those cuts. Or if it is the OD of the entire part, that's an easy change as well. But I think the biggest lesson here is, if any of you guys are designing in a facility where you have manufacturing in that same facility, go out and talk with the manufacturing side. See how they build parts, see how they weld parts together, see how the whole assembly goes with this design that works perfect in our CAD system, with a little thing called clearance that might be helpful when you get out on the shop floor. So understanding those things are going to help make better designers as well, because you're trying to follow that logic that they're using to assemble and put things together. So if you haven't, go take a trip out, ask some questions, right? It's a two-way street. Have a much better working environment, I think, if you do that. Hopefully you don't have wrenches thrown at your head when you go out to see why a print's not built correctly. Yeah. I left off a few dimensions, I'll admit that. All right. Getting into some of the kind of advanced topics, or not necessarily advanced, but topics that can help your model update more predictably, predict the way that it's going to update correctly, I should say. Sensors. Anybody use sensors inside of SolidWorks? One person, two people. Anybody know sensors are even there? They're kind of hidden right on the feature manager tree. But what a sensor allows you to do, I won't go into a big segue here, but it's one of the most underutilized functions, I think, within the program, because you can set your design rules and SolidWorks will alert you if you break one of those rules. It tells you. I have a rule that this part has to be, this thickness has to be no less than 1/4 of an inch. Now when I make a design change, it caused that to be less than 1/4 of an inch. SolidWorks will immediately tell me you're less than 1/4 of an inch. There's your little yellow indicator. It's not big and flashy, but you guys are going to see that in your tree and realize something's wrong, right? So it tells you that is now no longer 1/4, it's something less than that. So it's just following the rules you've set, but I don't have to think about everything every time I make a change. It just takes seconds to implement. You can also add comments to your design. This is a great feature for conveying that design intent to a future person making changes to that model, right? You're probably not going to own this part for the rest of your career. Other people are going to be involved in it, or if you switch jobs, right? So adding a comment per feature, you can date, timestamp, you can put in screen grabs now. This is all fairly new, last 4 or 5 releases of SolidWorks. This functionality has been there. So if you're not on 2020 or 2019, you still have this option. But it creates these on basically anything, a folder, a feature, a sketch, a plane, an axis, any of that can have a comment added to it. Anybody name features? We teach that in our courses, but I don't know that so many people use it out in industry. It's, for whatever reason, maybe people think it's a burden to have to rename something. Let's just leave it extrude 5, but you could do that. It just gives, again, that fellow coworker a little more knowledge to what this feature does. In this case, we did that manufacturing, so our first feature was the raw bar stock, and I could put that information in as my feature name. The symbols are still going to show if it's an extrude or revolve or shell or whatever that feature is, but just giving it a name is pretty simple to do. So a couple ways to do that. If you click on the feature once, hit F2, that brings up the text editor. You can immediately start typing. If you do a slow left click, so not a double click, but click, wait a second, click again, that also brings up the text editor where you can change the name. So you can rename features, sketches, planes, again, everything like I described before. Do you have a question on that?
No. I would say it's awesome if you define planes like bounding boxes and that type of thing. So you don't have to rethink, okay, what was this plane? Plane 23 doesn't mean a lot.
Yeah. I know exactly what plane 23 is. Yeah, and renaming a plane to be called bid plane, so I know that's what my symmetry is based off of. Yeah, things like that to help really convey that idea. Another option that has been out for a number of years, and this doesn't break parent-child relations like you might think it would, but creating folders in your feature manager tree and then moving features to those folders. SolidWorks knows that this feature is a child to this feature in another folder, so it keeps track of all that. But it makes it easier for you to organize and maybe group or simplify your tree by creating these different grouping folder names. And again, you can call these folders whatever you want. For example, we have a folder called reference planes, so any additional plane beyond top, front, and right, I can create new planes, give them names, throw them into that folder. Those are additional planes beyond the 3 that comes with the part. Core components might be your extrudes, fillets, things like that to give the rough shape. And then maybe I start creating detail features like cuts or patterns or things like that. You can organize it however you want. Just letting you know the option is there. Another great tool, if you're the one modifying somebody else's design, might not know how it was built or the way they did what they did. A great little tool here called Part Reviewer. Anybody use that feature? It's on the Evaluate toolbar on the Command Manager. So right there, the Evaluate toolbar. You get what looks like a little yellow part icon, but it's the Part Reviewer. It'll open up a separate task pane like I show over here to the right. And it's the same as taking the rollback bar and dragging it up and down the tree, one feature at a time. But this gives you kind of interactive play buttons. So it's like the DVD player, forward, backward, things like that. You can show sketches. I used to say VCR, but I got to say DVD now. Anybody know what VCRs still are? Okay, good.
Is it like a laser disc?
It's like a laser disc, exactly. Betamax, yeah, all that stuff.
Good.
The goal of home entertainment, right? So with the Part Reviewer, you do get that little interface. It makes it a lot easier, I think, to go from feature to feature or the sketches inside the features. You can also see comments. You can add comments. Just a great way to really, convey or see what somebody was thinking when they chose to do what they did. Dynamic references is a feature you have to turn on. Just a right click at the very top of the feature tree. So if I right click on the name of that part, I can turn on parent and child. That's the blue and purple arrows you see over here on the feature tree. That came out visually, again, 4 or 5 releases ago. Enhanced a little bit a couple years after that, but a great way to just quickly see where the parent or child features are. We all know that's important when you make design changes, right? You start changing a parent, it's a good idea. It's changing the children beyond it. If I change a child, it might not necessarily update the parent or have anything to do with the parent. It's just something downstream from that. Errors. Occasionally this happens. Not on my designs. I get them right every time, first time. But sometimes we have a few sketch dimensions or relations that make an angry sketch. We're over-defining it, telling it too much. I got to take a quick little joke on an old coworker friend of mine that, they modeled for 10 years, got into the reseller world, and, they're working on these files like this, and they realize they have a sketch problem. They had no idea that if you just simply click where it says over-define on that red piece of text, it pops up this wonderful little tool that says, let me help you fix that sketch. Right? Sketch Expert is the name of the command. And what Sketch Expert is doing is it says, I realize you're over-defined. Here are 4 possible solutions out of maybe many, depending on the complexity of your sketch. But here's 4 options to fix that sketch. And it actually will show you each one of those. You just cycle through, find the one you like. In this case, it was able to, we wanted to maintain this tangency right here. So they said, okay, fine, get rid of that dimension, and I'll be happy. You guys know you had that option? You do now, right? Okay. So that's the way to have SolidWorks help you. There's also a manual option. I never do that. I'm lazy. Let the automatic thing do it. But manual option is still a choice if you would like. All right, a couple more slides. Design intent inside of an assembly. So, sometimes it might feel like SolidWorks is, parts and assemblies behave. Getting them to behave, I should say, the way we want them to behave can sometimes be a little tricky. And design intent can be kind of an art, if you will, to try to get those things to work the way you want them to. But knowing how components react to each other, knowing how SolidWorks builds the assembly, can sometimes help guide that particular process. With poor planning, sometimes these features and assemblies, the parts don't always update the way we want them to. And what I mean by that is, sometimes it's as simple as that first part that you put into an assembly. You guys probably know your first component is always fixed. So insert the part first that needs to be fixed, right? If you're building a structure, welded structure, something like that, putting in a foot plate might be a good place to start. That plate's not going to move. It's fixed. I'm going to attach other stuff to it. If I'm making a rotary gear assembly on a shaft, I probably not put one of those gears in as my first component because I want that gear to be able to rotate. So maybe the shaft becomes the first component. I don't know. But thinking like that can sometimes be that little bit of forethought so that your assemblies will update correctly. Let's go back to that one too. Thinking about where the assembly is in relation to the planes might be another consideration. I typically, the first part I put into an assembly, I usually match that first part's origin to the assembly's origin, unless I'm making something that could be a symmetric placement of components. Then I might utilize, a mid-plane and place it off some distance. So there's a couple different ways to do that as well. It all boils down to what you're creating, what's your goal with that assembly. Did you guys know if you accidentally put the wrong component in first, you can always float and then reattach that part a different way, remate it? Okay. A couple other newer options that have happened over the last few years. This bottom one here is referring to a grouping of components, not a subassembly, but a grouping. So in this case, at our top level assembly, we have 4 parts that are all at the top level, but it's the same part just inserted 4 times. So what I could do is right click on the tree, and I can say group same components together. So it creates the component with a number 2 because there's 2 items, and then I can compress or collapse that, and my tree isn't quite as long because it's 1 item. There just happens to be 5 of them inside of that grouping, if you will. Okay. So nice way to try to simplify that tree. Adding folders, just like we did at part level, you can do that at the assembly level as well. I can move components into folders. Very common one is a fasteners folder. You guys probably follow suit with that. There are nuts and bolts and washers all into that fasteners folder.
How does the grouping work with pattern or weird components? Does it still grab them all and give them a full list?
So the question is, how does the grouping of components work with pattern instances? They're technically already part of that grouping. So I guess, let's say you have a case where I've inserted one pattern at 6 times, and I've inserted that same component again somewhere else on the assembly, and it's not part of a pattern. I can't say that I've ever tried that. I'm not sure.
I think you can't group components with features.
Got it.
Would be my guess.
I agree. So the guess would be that those part of the pattern are going to stay part of that pattern. The individual ones could group additional beside it, I guess, yeah. But not all inclusive. We could test it, right? How about that? Folders. So we talked about folders. There's some new colored icons for folders. Sometimes you might see an icon where it's the blue. That means everything is resolved. It's inside of that folder. Everything's there. If I see the white folder, everything in that folder is hidden. Okay, maybe I want to hide all my fasteners, create a display state, reopen the assembly. There's a checkbox to open to a display state, and you can say everything that's hidden, don't load it. Guess what? You just sped up your assembly performance by doing that. Okay, create a display state, hide components. Sometimes the components might be suppressed. That's the gray shaded icon. Now there are times when maybe 1 or 2 parts is hidden, 1 or 2 parts are suppressed, so you might see a combination of colors. That's what those colors indicate. Blue, everything's good. White or clear, hidden. Gray, something is suppressed. Okay. Mating components, I think this is somewhat simplified but maybe overlooked. When you choose to mate components together, sometimes using the default mate might not be the best mate. Default might want to make things coincident, but really I want it to be parallel or a distance. Using different choices there is not that hard to do, but try not to ever over mate. If you place a fastener into a hole, technically it can still rotate unless you lock rotation, which is another quick little trick. But adding another mate to make one of the faces parallel to the, just so it doesn't look like it'll rotate, or there's no minus signs. Anybody OCD enough that we don't want to see any minus signs next to our parts, right? So those are things that can over-define and really add a bunch of performance drag to that assembly. So be careful with over-defining mates if you can avoid that. Another one, this is such a simple fact that when you build assemblies, build them just like production is going to build them. There's your subassembly. If they put these 6 parts together, make those 6 parts a subassembly. It's not rocket science. It's super easy to follow. Okay. Talk a little bit about display states. Newer command, last, 7, 8 years probably. But display states are a nice way to do what configurations used to do, and they're not as CAD heavy. So display states aren't near as bad if you just want to hide, show, or change the display of something. Maybe I want this part to be transparent, everything else to be shaded with edges. That's a display state function. So those visibility settings, like everything I show here, that can all be done with 5 different display states. No configurations needed. So configurations are handy if you're going to change dimensions, you're going to replace components, change mating conditions, things like update. Find what works for you. Test out a couple of ways. Find what works. The trick is getting your entire staff to do the same thing that you just did, and that can be tricky. The larger the staff, right? But I think if you have, I've seen a lot of companies that will do lunch and learns for lunch, like 1 day a week or 1 day every 2 weeks. They'll buy some pizzas, they'll bring people in their conference room and just throw out an idea. And I hate it when sheet metal does this or whatever. Well, there's a good chance a coworker might know why it's doing that or another way to do it that way. And just share your ideas, right? You're all making designs. Get everybody working on the same page. It's wonderful. Take that little bit of time to think about your design. Think about not only how it will evolve, but how that information can be used to build for production, other information about that. And last but not least, let's try to have fun. We are working with almost video gaming software is how I kind of related from the 2D AutoCAD world into the 3D stuff. It was like getting paid to have fun. Wonderful, right? So yeah, have fun, try something new. Go to a forum, call up your VAR, ask some questions. Ask Eric, he knows the answer to just about everything now. Wonderful user group leader. That's all I have, guys. Thank you.